Well, hello everyone, and thank you for coming to my talk, Windows Security Research, a practical guide for beginners to find 0 days. And as you can see, I'm not really a graphic designer, so it will be some simple slides, but we have around 200 of them, so I hope you are relaxed in your seats. Okay, yeah, so a little bit about me. My name is Oliver Lyak, and I work as a penetration tester at the Institute for Cyber Risk. And I've been in cybersecurity for about 5 years. I am the author of Certify and some other things, and I blog sometimes on research.ifcr.dk. And I also do Windows security research on the side, which resulted in 7 Windows CVs in 2022, and I have hopefully more to come. So a little bit about what we will do today is that we will get a behind-the-scenes look at the process of finding 0 days. And so we will take a look at how do we find the inspiration, how do we even know where to look in this big jungle, and also how do we look, how do we make a proof of concept, how do we make some impact with an exploit, and finally, how do we make a good report. And we're doing it for fun and profit. And we will do it by looking at 5 of my own CVs, and we will look at how did I find them, some of the tools I used for testing and debugging, and also how did I find the documentation and information needed. And of course, you will see some different methods and techniques. But I want to let you know that the technical details of the vulnerabilities have been simplified a bit because that is not the essence of this talk. The essence is to find some methodologies on how to proceed. So a little bit about my expectations for you to understand this talk. I expect that you have some Windows knowledge and some technical knowledge, and that you can mix that with a creative mindset. So I made this graph. If you don't know what Windows is, that is a 0. And if you read both parts of Windows Eternals and you understood everything, you are a 10. And if you are around 2 to 3, so you have some familiarity with Windows, then you should be able to understand 50 to 75% of the talk. I don't expect anyone to understand all of it because there will be some technical details, but those are not the things that matter. Because the goal is to give you inspiration about the methodologies, the tools, and the mindset you can have when you want to pursue this. So the goal is not to make you understand all the technical details. So let's get started. A little bit about the tools that I will show here. I know it's a bit dark, but I will be using several tools from the sysinternal suite. And this is a bundle of utilities for various purposes. So I definitely recommend that you just take a look at all of them and start reading about what can they do and how can they help you. And we will see if some of them in action. So the first CVE we'll talk about is also my first CVE that I named Spoolful, and it was a local privilege escalation in the Windows print spooler that received a CVSS score of 7.8. And the method we will be using is bypassing security patches. So we have some vulnerability, we didn't find it, but it gets patched. And then we take the patch, we analyze how did Microsoft fix this, and then we try to come up with a bypass, and that may result in another patch, and so on, so continue forever. So back when I started my journey, I had absolutely no idea about any of the techniques and tricks you could do in Windows. So of course I needed to learn about that, and I started reading a lot of blog posts. And for the first part, we will be looking at a bypass technique that I learned about. And there are 2 vulnerabilities. There's one called print daemon, and then another one called long-lived print daemon. So the first one is a vulnerability that was found, and the next one is a bypass that someone made for the patch that Microsoft came up with. And so now that I had a bypass technique, I actually needed to go and find the vulnerability, apply this bypass technique. And so I read a blog post about this CVE, and the bypass for that is Spoolful. So before we get started, we need a small introduction to the print spooler. And the print spooler is just a service that is running in the background on Windows. It is installed by default, and you can see that it will be running as the local system account, so it will be running with almost the highest privileges you can get. And we can also take a look at the properties of this service, and we can see that the program that is running is spoolsv.exe, and we can see it will automatically start up whenever the computer boots. So the print spooler service is this box down here, and these are just some of the components that makes up the print spooler service. Obviously, we have the spoolsv.exe that we talked about before, and the way we can communicate with that is through something called remote procedure calls. And you don't need to understand remote procedure calls for actually exploiting this, but I definitely recommend you to take a look at remote procedure calls and understand them if you want to do Windows security research. So we can have our application up here, and then we actually just include a library called winspooler.drv, and then all the functions we want to call and the way we want to interact with the print spooler. Well, the winspool.drv will take care of all the remote procedure calls and everything. So let's take an example. We have the add printer function, and the add printer function will add a new printer to either the local machine or remote machine. And you can find this in the Win32 API documentation about printing. And so you can see a little bit about the function definitions, the type of parameters, and so on. So this is just to give you an example of what it might look like. Well, in our code, we will call add printer, and then the winspool.drv will take care of everything, communicate with the print spooler service. And then we have another component called spoolss.dll, and basically the execution goes on to that one, and it will say, are you trying to add a new printer locally, or are you trying to do it like administrating a remote server? And so depending on the case, if we're trying to add a new printer locally, the functionality will be in local spl.dll. Otherwise, it will be win32 spl, which will actually go all the way back to some remote print spooler service. So for privilege escalation, we want to focus on this one. Okay, so you might be thinking, but no one really uses printers anymore, and that is partially right. But by default, you get these two printers installed on your Windows installation, and some installations even come with a third printer if you have one node installed. So everything is installed and enabled out of the box. And let's take an example for the Microsoft Print to PDF. It is not a physical printer, but it is what allows you to go onto a website and right-click and print, save it to a PDF. So it is just to show that the print spooler service is running and enabled on all machines, unless you disable it. So you should be able to understand the basics, but if you don't, this is the part, if you don't understand all the technical details, it will also be fine. So let's take a look at the bypass technique that I learned about. The first vulnerability was the print daemon. It got the CVE 2020-1048. And essentially, I was reading about it in a blog post from Yadin Shafir and Alex Ionesco, and it was released on May 2020. And yeah, it was released in May 2020. And the point was that a user could write to an arbitrary file by creating what is called a printer port. And the printer port is what defines where the printing data gets sent to. So if you have like a remote printer, you could say that the printer port is TCP/IP, or if you plug the printer directly into your computer, you could say that it was a USB port. But it could also be a file. So the exploitation is pretty simple. We add a new printer, and the name will just be mycoolprinter, but the port is file, and then some file that we want to overwrite. In this case, we're just overwriting the calculator, but obviously we want to overwrite some critical executable. And after that, we just say write printer, mycoolprinter, foobar, and then inside the print spooler service, it will say, oh, this is our printer, the name is mycoolprinter, and the port is file, the calculator, and so it will just write foobar to the calculator. So it's a pretty simple vulnerability, actually. And the patch for this was that inside the print spooler, whenever you try to add a new printer, it will check, is the user who is calling me, is the user allowed to create and write to this file? So if the user is not allowed to do it, then they cannot create the printer, you get an access denied, otherwise it will create the printer. So the bypass for that one is this cool CVE 2020-1337. And I was reading about it in a blog post from Paulo Stagno that was released in August 2020. And it was actually reported by 11 different people. So 11 different people received acknowledgement on Microsoft reporting it. So you can imagine the bypass must also be pretty simple. And it just uses symbolic links for bypassing this. And symbolic links can be a bit of an abstract concept, especially on Windows where you have so many different types of symbolic links. But essentially, a symbolic link, in this case, it's what's called a junction folder. So it's some folder that actually points somewhere else. So if we try to list the files inside some folder, we will be listing the files inside C Windows task. And this folder is just a generic folder that everyone can write to, and we will see why that becomes important. So first of all, we create a symbolic link, some folder that points to C Windows tasks. Then we create the printer, mycoolprinter again, and the port is now file, see some folder calc.exe, and so the print spooler service will check, are we allowed to write to some folder calc.exe, which is really Windows task calc.exe, and everyone is allowed to write to that folder, so it will go on and create the printer. Now we change the symbolic link. So we make some folder point to Windows System 32. And then we just write to the printer. So we write foobar, and inside the print spooler, it will see that the port is still some folder calc.exe, but now some folder calc.exe points to Windows System 32 calc.exe, and so you can write to that file. Now, a little bit about where did I even apply this technique, that is CV 2020-1030. And I read a blog post from Victor Mata, and it was released in November 2020. And essentially, whenever you are printing, so whenever you're using a printer, a temporary print job file will be written to a folder called the spool directory. And you can define the spool directory for each individual printer. So one printer can have one folder where it writes the print jobs, another printer can have another folder, and so on. But it is essential that the folder allows everyone to write files to it, otherwise they cannot print. And the thing here is that whenever the spool server starts up, it will check all the printers to see if there's a spool directory defined. And if there is a spool directory defined, it will create the folder if it doesn't already exist, and then allow everyone to write to the folder. So this is the registry. If you're not familiar with the registry, for now you can think of it as a big key value database, but I will definitely recommend that you get more familiar with it. But essentially here we can see that the default spool directory is set to Windows System 32 spool printers, and we can take a look at the permissions for that folder with the icackles command, and you will receive some output like this, which even to me can be confusing. So we can also use a more user-friendly interface, and we can see that users have the create files and create folders permission. Now, I mentioned that you can define this spool directory for each individual printer, and it's just another key, in this case for Microsoft Print to PDF, but we see that it is empty. So in that case, it will use the default spool directory that just saw was defined. But we cannot, as users, change this. We only have the read permission to change the registry key value. But luckily, the print spooler has an API for actually changing all these registry key values. So even though we cannot edit the registry, we can make the print spooler operate on the registry keys for us, namely with these functions, enum printed data, get printed data, set printed data, and delete printed data. So if we want to change the spool directory, we can say set printer data, my_printer. We want to set the spool directory to spooldir. And so the print spooler will actually update the registry for us. It will not create the directory yet. That will happen when the print spooler service starts up. So when the print spooler service starts, inside the build printer info, the print spooler will go through all the printers in the registry. It will see if there's a spool directory defined. And if that's the case, it will create the folder, but only if it doesn't exist. And if it's also creating the folder, it will update the permissions to allow everyone to write to it. So we can make the print spooler create arbitrary folders for us. How can we exploit this? Well, the arbitrary folder creation with writable permissions primitive can be exploited in many different ways. And one of the ways is actually using the print spooler service itself. So there is this function called setPrinterDataX, which basically we can make the print spooler load a DLL, a shared library, if it is inside the printer driver directory. Now this is just another folder path that I have replaced with this value because it's a long path and I don't want to write it in every slide. It would be too much. But if we can create a folder inside the printer driver directory and then we can put our malicious DLL inside that folder, then we can have it loaded into the print spooler service. And the bypass for the patch for this one is spoolful. And so the patch looks something like this. Whenever we're trying to update the spool directory, the printer spool service will check, are we even allowed to create this folder? If we are, it will update the spool directory registry key value. Otherwise, we will get an access denied. And this looks very familiar to something we've just seen in the first patch. So this is the patch for the first vulnerability that I showed. Is the user allowed to write to this file? And we already know how to bypass that one because we saw the bypass technique. So let's see a speed run. First, we create this symbolic link that spooldir points to see Windows tasks. Then we update the spool directory. Is the user allowed to create this folder? Yes, we are, because it's in Windows Task, and we can write to that one. So it will go ahead and update the spool directory. Then we change the symbolic link to point to the printer driver directory. And then we restart the spooler service. And this technique to restart the spooler service, you can read more about it in the blog post, but we can actually force it to crash and start up again. And so whenever it starts up again, inside the build printer info, it will look in the registry, see that spool directory is spooldir v4, which actually points inside the driver directory v4. So it will create the folder and allow us to write inside the driver directory v4. And so now we have this nice DLL that we are ready to place inside the printer driver directory that was just created. And we are very excited, but something just didn't work. So it's time that we look inside how did they actually patch this vulnerability. And there are many great resources on patch diffing. And my way of doing it is definitely not the best way, but I copy all the files I need before I update Windows. And then after I update Windows, I copy all the files again. And then I can compare the old versions and the new versions in Ghidra, or IDA, or whatever tool you like to use. But there are some more efficient ways where you don't have to update your computer. You just download the update and do some magic tricks to extract the new files. And on top of that, Microsoft lets you download these PDB files, which are simple files, so all your functions can be named nicely, and it makes the reversing process way easier. But in our case, Victor Marta, in his blog post, he already explains the functions that are relevant, namely the set printer data x, where we update the spool directory, and the build printer info, where the actual directory is created. So we just need to take a look and see if there's some new security checks going on. And inside the set printer data x, we see that there is a new function called isValidSpoolDirectory. So that already sounds like a security check. And this is what the decompilation of that function looks like. You don't have to understand everything. Here we have two calls to create file, and that is essentially what is checking are we allowed to create this directory. But right before that, we actually have a call to a function called adjustFileName. I will not show the decompilation of that one, but basically, if we have our symbolic link spooldir v4 that actually points to see Windows task v4, then the adjustFileName will take that path and expand it into an absolute path. And this absolute path has a bit of a weird format, which we will not talk about here. But this weird format is very different from just expanding the path. So what actually happened when we tried to update the spool directory is that, I'm sorry if it's a bit dark, but the adjustFileName function was called. And so it will check, is the user allowed to create this folder, see Windows task v4, and then that's actually the absolute path that it will write inside the registry key. So obviously Microsoft has seen this bypass trick before, and they tried to be smart about it and expand the symbolic link into an absolute path. But that just requires a few bypasses that you can read about in the blog post. There's also a full exploit if you would like to read more about how I coded it and interacted with the print spooler service. But the takeaway of this is not the technical details, but I want to focus on reading a blog post about vulnerabilities, bypasses, and general techniques and methods just to build up your arsenal of techniques and methods and also get inspired to actually go on hunting. And you shouldn't be afraid to analyze a patch and come up with a bypass. In this case, as you can see, it was really simple. And rumor says that symlinks are Microsoft's #1 enemy, and they actually once removed it from their scope for bounties because they received so many vulnerabilities with symbolic links. But luckily it's back, maybe because people stopped reporting them. And there's this nice GitHub repository by Google Project Zero, where they include various different tricks for symbolic links, and you can go and check it out. There are so many cool tricks, like winning a race condition with a symbolic link. Okay, the next. Thank you. The next vulnerability we will talk about is an Active Directory domain privilege escalation that I named certified, and we will see why that is the case. And it received a CVSS score of 9.0. So the method we will be using is just read the manual. So you read some information and documentation someplace, and then you read some more documentation information, and you start to realize there might be a vulnerability here. But the inspiration I actually had for Go and Hunting was that I, again, was reading a blog post about 2 other vulnerabilities, and I was thinking, can I find a similar vulnerability in a similar component? but we will actually look at how you could have found this vulnerability by just looking at the documentation. So a little bit about Active Directory. Usually when people mention Active Directory, they are referring to Active Directory domain services, and that is because Active Directory is just a variety of different services that are all working together. So we have, for instance, in the Active Directory domain services, we have a domain controller, which you can think of as a big database that supports many different protocols that can connect all of this. So a lot of the concepts that you know from your local Windows installation just expanded into a huge organization. So for instance, we have an administrator who is a member of the domain admins group. So the domain admins group can manage the whole domain. But we can also have regular users like John, who's a member of domain users. And then we can also have servers. So John can go to a server and access the file share, for instance. And one of the authentication protocols in Active Directory is Kerberos, and they use this concept of ticket-based authentication. So John can go to the domain controller and say, can I have a ticket? I want to log on to server.coop.local. And the domain controller doesn't know who John is because he hasn't proved his identity yet. So the domain controller wants him to identify himself. And so John will send his credentials to the domain controller, but actually in Kerberos, the password is not sent to the domain controller. John just has to prove that he knows the hash of his password because the domain controller knows the hash of John's password. So he does that by encrypting a timestamp with his hash. And so when he proves that, the domain controller will create a ticket for the user John at corp.local to server.corp.local. And now John can take this ticket and present it to the server as a means of authentication. Another key component of Active Directory is the certificate services. It is not installed by default, but is installed in almost all real-world environments. So John can go to a certificate authority. I should mention that the certificate services is the public key infrastructure and certificate authority services that are integrated into Active Directory. So that is why it's interesting. So John can go to the certificate authority and say, I want a certificate, please. And of course, the certificate authority don't know who John is yet. So John will, again, prove his credentials to the certificate authority, but the certificate authority still doesn't know who John is. So the certificate authority will go to the domain controller and ask, is this true? And then the domain controller will say, yeah, it's true. And the user principal name, UPN, for John is john@corp.local. And so the certificate authority will create a new certificate with the UPN, the user principal name, john@corp.local. It will sign it and give it to John. Now John can go to the domain controller and say, now I want to log on to the server.corp.local. Can I have a ticket? Again, identify yourself. Well, I have this certificate that proves I have the UPN, john@corp.local. It is signed by the certificate authority, and you trust the certificate authority. So we get a ticket. And again, we can present that ticket to the server. Now, in Active Directory, it's not only users that are accounts. Servers and computers in general are also accounts in Active Directory, so they have a logon name and a password as well. So the server.corp.local can also go to the certificate authority and say, I want a certificate, identify yourself. And again, the username here is then server $. So a common thing for computer accounts is that they have a $. At the end. And the password is usually random. And again, the certificate authority will go to the domain controller, verify everything. But in this case, it will say that the domain controller will say the DNS name is server.corp.local, so not a UPN. So the certificate authority will create a certificate with the DNS name server.corp.local. So this is the difference between users and servers. But again, now the server can go to the domain controller and say, I want to log on to dc.corp.local, which is the domain controller. Can I have a ticket? It says, identify yourself. Well, I have this certificate with a DNS name saying I am server.corp.local. And everything checks out. You get a ticket for the user server $@corp.local to the server dc.corp.local. And finally, we can present the ticket as authentication to the domain controller. So you might have noticed something weird here, or strange. How did the domain controller know that the DNS name server.corp.local actually belonged to server.corp.local and then made a ticket for server $@corp.local? Well, this is called a certificate mapping. So the domain controller has some way of mapping this value into an account. And to understand that part, I want to introduce you to the Windows protocol documentation. And it seems that they have a protocol for Windows protocols. Maybe it's a specification. I don't know what they call it. but you can find it on this link. And when you open up that page, you will see technical overviews, 111 minutes to read, so almost 2 hours. But this is just for the overview. Short descriptions of each protocol takes 2 hours to read. So they have all the Windows protocols in there that you can imagine. And the two protocols that we are interested in is the Active Directory technical specification. So that specifies the core functionality of Active Directory. And then we have public key cryptography for initial authentication in Kerberos protocol. So that is what allows us to use a certificate to authenticate ourselves. And inside the MS-PKCA, so the PK in it, we see that there is a section for certificate mapping. And so it says implementations of PKCA KDCs which use Active Directory for the account database when the user account control attribute bit WT or ST is true, validate certificate mapping using the SAN DNS name, both false, validate certificate mapping using the SAN UPN name. This is Microsoft documentation. It can be so confusing, especially when you're not used to all these terms. But essentially, if it's a workstation or server, so if it's a computer, then look up the account using the DNS name. Otherwise, look up the account with the user principal name UPN. So an example of the UPN is the john@corp.local. An example of the DNS is the server.corp.local. And that is because objects in Active Directory are just a collection of different attributes and also some definitions of what should these objects look like. So even though users and computers are both accounts that have a password and a logon name, they are two completely different objects. So they will have two completely different attributes. There will be some overlap, as we can see here. I'm sorry, it's a bit blurred. But on the left side, we have the user object, and we see the object category is person, and it has an attribute called SAM account name, Jane. That is the logon name. And then it has a user principal name, which is jane@corp.local. But on the right side, we see that the object category is computer, and the SAM account name is johnpc$. But we don't see any user principal name. Instead, we have the DNS hostname attribute that says johnpc.corp.local. And this tool I'm using here is AD Explorer. It's from sysinternals, and it's one of my favorite tools for actually interacting with Active Directory. And that is why when we want a certificate for a computer, we get the DNS name, which comes from this attribute. And when we do it for a user or person, we get a UPN, which comes from this attribute. So that is why we see two different ways of doing it. So why they're not using the logon name, I don't really know, because they both have a logon name. But if we try to update Jane's user principal name to john@corp.local, then we get something called a constraint violation. And that is because John already has the user principal name john@corp.local. But where is this even defined? Well, it's defined in the documentation. So in the Active Directory technical specification, we have a section called uniqueness constraints. And basically it says user principal name uniqueness is checked. So we cannot have duplicate UPNs unless some system administrator really thought it was a good idea. But what about DNS names? Well, this is the full section. It's very small, but I have highlighted, we have one check for the UPN, the user principal name. Then we have something for a service principal name, which is another attribute, so an SPN, and then an SPN alias. But it doesn't mention the DNS hostname anywhere. And that is the essence of certified. DNS hostname attributes are not unique, so we can create a computer account with the same DNS hostname as the domain controller, for instance. And by default, all users can create up to 10 computer accounts. So the idea is to create a computer account with the same DNS name as some server that we want to impersonate. Then we get a certificate. And finally, we use the certificate for authentication. And if you're a domain controller, you can perform what's called a DC sync attack. So this is the difference between a proof of concept and an exploit. An exploit, we actually make the impact and show how we can use it for something. And DC sync is the way that domain controllers synchronize. So if you have multiple domain controllers in a domain, they need to update their different information about the users, so they synchronize itself. And so we can just ask a domain controller, can we just please have the credentials for all the users? We need to synchronize that. So let's see the speed run. John wants to create a new computer, and the logon name is just johnpc$. His password is not very safe, but he sets the DNS attribute to be dc.corp.local, which is the same value that the domain controller already has. But there's no problem with that, since there's no uniqueness check. And so John PC can go to the certificate authority, ask for a certificate, identify yourself. Well, these are my credentials. Again, the certificate authority will verify it with the domain controller. And it was a yes, the DNS is dc.corp.local, so the domain controller doesn't even care that there might be a vulnerability here because that is how it works. And so the certificate authority will go ahead, create a certificate with the DNS name dc.corp.local. Now John PC can go to the domain controller, say I want a ticket, identify yourself. Well, this is my certificate. It says that I have the DNS name dc.corp.local, and so the domain controller will just say, yeah, okay, here is a ticket for the user DC dollar, so itself, to the server dc.corp.local, and finally we can take the ticket and say, give me all your information. So the full technical details is on my blog as well. You can read all about, there were some small hiccups, some small things we had to do, so you can read all about that, and also more deep dive into certificate services. But the takeaway, again, is not the technical details, but more about the methods and mindset. And here I say that you shouldn't be afraid to open up the documentation. It will be full of confusing terms and TLAs, so three-letter acronyms. So take your time and don't get scared for the first time you see all of this, because we don't need to understand everything. I definitely do not understand everything in either of these two protocols, but we just need enough to notice there is something weird going on here. And simple vulnerabilities like this can happen because Microsoft Windows has many, many different protocols that are working together, and they need to be consistent on the way they use users' information. And again, finally, AD Explorer from sysinternals is a very great tool that I like to use for browsing and editing objects in Active Directory. Now, thank you. The next vulnerability we will talk about, I didn't give it a name, probably because I didn't make a blog post about it, but it's another Active Directory domain privilege escalation that received a CVSS score of 8.4. So not 9.0, but 8.4. And the method we will be using is something I call shifting. So we have some vulnerability that was found in some component, and it gets patched. We didn't find it, but we can read about information about the vulnerability and also the patch. So we take that information, we try to adapt it into another vulnerability in some component. So a different component, but maybe the same idea behind the vulnerability, can we find it somewhere else? And the same, the inspiration is the same as the previous vulnerability. I was working on this tool, but this is actually the thing I wanted to exploit in the first place, but then I ended up finding the previous vulnerability, and I didn't even mean to. But I was reading a blog post about these two CVEs from Lyak, and I was thinking, can I find a similar vulnerability in another similar component? So, oh yeah, we need some introduction, but we have already been here already. And that was just to show that even though there's a lot of new stuff when you first join the Windows security research, the more you learn, the more you will feel comfortable about all of this stuff. Oh, so these two CVEs, I was reading about them in this blog post by Lyak. And the blog post was released in December 2021, and it abuses a weird behavior, let's call it, in Kerberos tickets. So let's see it in action. Here we have John. John wants to create a new computer. And so he says the logon name is DC, but there's no dollar. But the domain controller has the logon name DC dollar. Nothing is wrong at this point, at this time, before the patches. And then John PC says, I want a ticket for myself. As we know it, identify yourself. Well, my logon name is DC at corp.local, and this is my password. And that checks out, nothing weird yet. So we get a ticket, and there is no dollar in the username, which also matches with our logon name. Nothing weird yet. But then John comes along and says, I want to update my computer's information. I want to change the logon name to John PC. And there's nothing wrong with that as well. But we still have the ticket for DC at corp.local. And so when we now go to the domain controller, we can present the ticket and say, I want a new ticket, and I want to use this ticket as my authentication that I am DC at corp.local. And then the domain controller will look at the ticket and say, dc.corp.local, I made this ticket, but I cannot find any user with that logon name. But what if I forgot to add that dollar at the end? Is there some account that maybe has the DC dollar name? Yeah. So I wasn't going crazy. There is an account that exists, DC dollar. That must be the one you were talking about. So here's your ticket. Now you are DC dollar. And now you can get all the information. So that was a pretty weird thing, but Microsoft Windows, they want it to work, and then security comes next. Don't make a citation for that one. So obviously we're simplifying things a bit, but you can find the full technical details. But the thing about the dollar is real. So the domain controller could not find any account, so it just tried to add the dollar and see maybe that worked. And I started to think, does this work with certificate services and certificates? So the patch fixed the confusion with Kerberos tickets by including some extra information. And it also prevents default users, so low-privileged users, from creating computer accounts without the dollar. So that is one way to approach it. But sometimes in big environments, especially in big organizations, you have some generic user, in this case Jane, that has full control over John. So just two low-privileged users, and Jane can control John fully. So she can change his password, his name, whatever. So Jane goes to the domain controller and says, I want to update John's information. I want his user principal name to be dc@corp.local. And there are two things to notice here that I want to demonstrate. First of all, computer accounts don't have a user principal name. So even if we made it dc$@corp.local, there would be no issue. But on top of that, I'm not even adding the dollar. So let's see how it works out. Then Jane goes to the certificate authority, says, I want a certificate, identify yourself. And then Jane knows John's credentials because she just changed them. So the username would be john@corp.local. This is the logon name, not the user principal name, which is a different attribute. And the password that you just chose, Johnny123. And again, the certificate authority will check up against the domain controller. And the domain controller say, yeah, and the UPN is dc@corp.local. And so we get the certificate with the user principal name dc@corp.local. And now Jane comes and say, I want to change John's user principal name to be just john@corp.local, but we still have the certificate. So you see how this is very similar to the previous scenario. Now we have a certificate with the user principal name dc@corp.local, and we go to the domain controller, we say, I want the ticket, and I have this certificate claiming I am dc@corp.local. And so the domain controller once again thinks, I cannot find any user with that user principal name or even a logon name, but maybe someone forgot to add that dollar. So let me check if there is an account with the DC dollar logon name. Well, yep, there is. And so here we get the ticket. And there are two things to notice here. First of all, it still did the dollar trick. So that was our inspiration for actually going and finding this vulnerability. But it also, the documentation said that if it was a server computer, it should use the DNS name. But somehow we used the UPN to map that to a server. So that is pretty weird. But we can use the ticket. We don't mind. We got the CVE. we use the ticket and perform the final attack. And there are more technical details. I didn't write a full blog post about it, but I do mention it in a blog post on Certify 4.0. But the takeaway is, again, to read blog posts and try to adapt a logic bug from one context into another context or component. Because if this logic bug happens in one place, chances are that it might happen somewhere else. And we saw that with the dollar, that even though they fixed it in Kerberos, they didn't fix it in the certificates. So the last two CVEs I want to talk about is arbitrary file read in the Windows print spooler, so the print spooler again, and they both received the CVS score 5.5. And the method we will be using is called dump dynamic analysis. So we start some logging, debugging, monitoring tools, then we start to play around with the component, maybe in a dumb way, and then once we're done playing around, we analyze the logs that we just collected, and maybe we can spot a vulnerability. So the inspiration I had for this was that 2021 was a very good year for the print spooler. 16 vulnerabilities were reported and patched in 2021. So I was thinking there must be more. And even a fun fact, in 2022, 35 vulnerabilities were found and patched in the print spooler. So that's on average every month, 3 vulnerabilities in the print spooler were patched. And in 2023, we already have 3 vulnerabilities, and we have Patch Tuesday coming up, I think, next week. So maybe there will be some more vulnerabilities in that. Patch Tuesday is that every second Tuesday of the month, Microsoft will release all their security patches such that system administrators can be ready to update the systems. But in any case, dynamic analysis is analyzing a program while it is running. So one way of doing it is by debugging a program to analyze the memory, the registers. Maybe you can make it crash and inspect the state. But another way of doing it is monitoring events triggered by the program. So if the program tries to create a new file, we can get an event for that. Maybe it's trying to update the registry keys and so on. And the tool I like to use for that is a tool that I use a lot. It is Process Monitor from sysinternals. So I'm almost always running this tool in the background whenever I am playing around with the components. And it can just stand there and collect some events. And basically, it's kind of like Wireshark, but just for events. So you can make very specific filters about what you want to capture. So in this case, we just say we just want to capture all events coming from the process spool sv.exe. But you can also filter on something like, I want only file operations. Maybe I want to see only DLLs that fail to load. So this is how you can find DLL hijacking vulnerabilities. You can just create a filter that says, all DLLs that fail to load, I want to see them. And so once we start it up, we can see some different events coming, and that is just by opening the settings and listing the printers that are there. So we will get a lot of events, and you can see some of them are pretty similar to each other. So maybe we want to start filtering out, excluding all these generic events. And for each event, we can go into the properties of the event and read some more information about what really happened here. We can also see the process that triggered this event. And finally, we can see the whole stack trace for this event. So all the functions that led up until this point. So we have the RPC library, the remote procedure call library is also included here, all the way into the kernel. So we can find all the functions. And we see here we have the spool sv.exe and the relevant functions here. And that we will come back to in a bit. But DOM dynamic analysis is then that you start your monitoring, so your process monitor, for instance, and then you just play around with the application in many different ways. So APIs, graphical user interfaces, you can do expected things, unexpected things. You just want to create as many events as possible. And then you analyze the logs. And then you ask yourself, is there anything that seems interesting? So even after you collect the logs, you maybe want to filter out all of the events that are not relevant for you. So if you're looking for file system vulnerabilities, just remove all the registry events. And so that is exactly what happened. I was just playing around with the print spooler, and I noticed that the print spooler was reading some registry key value. Let's say it's called some file. That was the value in the registry. And then it tried to open some file in some directory. So it looks something like this. It tried to check the value in v4 merge config file name, which had the value property here. I put it. And then it tried to open the file inside this directory called property here. And a lot of the time when I am actually testing vulnerabilities, I cheat by making myself an administrator and actually doing stuff in the registry, for instance, because we can do a lot more as an administrator than as a low-privileged user, and we can do it way faster. So for instance, we can open the registry, change the value as we just saw. I put property here, and then we can observe the behavior. And then we can ask ourselves, is there possibly a vulnerability? No. Then we just move along. We just saved a lot of time trying to make a nice proof of concept in C# or C++. If there is something that looks very interesting, then we can make ourselves a low-privileged user and then make the proof of concept in code just to fail fast, because a lot of the time you will be in the no, so you don't want to spend too much time there. You want to spend your time in yes. So one example is that we can change the registry key values as an administrator, or we can do it with the print spooler API as a low-privileged user. So we can do all our testing in the registry where it's super easy to update, or we can use the print spooler API once we know there is a vulnerability. So save yourself some time, fail fast, and move on. But be aware that you can get some false positives where it's working as an administrator, and then you try to do it and it's not working, and you get a bit sad. So I was asking myself this question: can I set the value using the registry as a low-privileged user? The answer was no. But can I do it with the print spooler API, the set printer data? And the answer was yes. And finally, why is it trying to open this file? Can I somehow get the contents of this file? And that the answer to that one was yes. But at this point, we can just read some arbitrary file in some folder. So I was thinking, how can we maybe make it more interesting? And the answer to that is path traversal. So if we define a file name that has // sequences, so it moves upwards in the directory, then basically that is our data // blah 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 secrets flag.txt, and it actually tries to open that file, and we could get the contents of it. So at this point, it turns out there was some configuration value that specified the file name of something, and I knew that I could set the configuration value with set printer data, and I knew I could get the contents using get printer data. But I had really no idea what was going on because I was just playing around and I didn't reverse a single line of code. I didn't write any code. I was just browsing around. But we found a vulnerability for arbitrary file read. So perhaps it's time to understand what really happened. And this is where this stack trace comes in very handy, because we can see all the functions that were involved in generating this event. And we can see that the enum printer data function is actually the one that goes into the registry, checks the value, and gives us the file contents. So we can see we can see the spool sv.exe, local spl.dll, and printconfig.dll. So it's 3 different components, 2 DLLs that you wanted to analyze, reverse engineer, and find some relationship between them. Or with dynamic analysis, you can see the relationship immediately that the SPL enum printer data calls into the print config. So we already know the relationship, and we already know where to look inside these 2 binary files. And so I did some analysis on the vulnerability, and I had a rough idea what was going on. I still do not know what this was even intended for, like what is the functionality. I didn't know. I just knew how to trigger it and why I did it. And so how to get another easy CVE? Well, we have just inspired ourselves with one vulnerability, so why don't we just take a look around, see if we can find a similar vulnerability. And it turns out that the file that the long directory path you saw, there was also a registry key for that, and that one was also vulnerable to path traversal. And so that is why there's 2 CVEs here. And the takeaway from this is that dynamic analysis is a great method for both understanding functionality, but also spotting vulnerabilities. So as I mentioned before, I just run it in the background because whenever I'm interacting with a service or a component, I can actually tend to see, okay, it was trying to open this file. So even though I'm not trying to spot a vulnerability, I can start to understand the application way better. And don't get stuck in your hunt with writing code, and you spend hours and hours of writing some code that probably shows no, and you could have found out immediately with administrative privileges. So unless you really need to, then try to keep it simple and move on fast. Yeah, look around when you find the vulnerability, because as before, if it happens in one place, it might happen somewhere else. These are the same developers, same mindsets, not necessarily across protocols, but for the print spooler, it might be the same developer who made one mistake here and another one there. So now that we have a proof of concept, we want to turn it into an exploit. So the difference between a proof of concept and an exploit is that in the proof of concept, you just prove there's a vulnerability. So if you have remote code execution, maybe you just make it crash, or maybe you show that you can get control of the instruction pointer. But the exploit is actually abusing the vulnerability into some impact. And we want to maximize the impact from the primitive we have. So we saw before, we have the file write, for instance. We also had the folder creation primitive, and those can be turned into privilege escalation. You just Google file write privilege escalation, and you will see tons of blog posts. So once you obtain these primitives, you can turn it into an actual privilege escalation. And for the file read, I didn't find a way to do it yet, but my best way of doing it was possible privilege escalation. And that is because there is a file on Windows which contains the credentials of all the local accounts, but it is locked while the system is running. But if there is what is called a shadow volume backup, so if there's backgrounds in the running in the background, then we can actually read that file from the backup. So why does a good exploit matter? It's not just about a good exploit, it's about a good vulnerability submission. This page is taken from Microsoft's bug bounty program on Hyper-V. And here we see that if there is a remote code execution with a functional exploit and a high report quality, that can result in $250,000. But if there's no functioning exploit and a low report quality, you can get at maximum $50,000. So don't get fooled by these numbers. This is the maximum, so they can pay you $10,000 if they like to. And they do a pretty good job of explaining what is a high quality report, what is a low quality report, so the type of information you should put inside your report. So for instance, a high vulnerability report, you can see that it's all the previous one plus these two. So for a high report quality, you also make a detailed and correct analysis of the vulnerability. So obviously, you have to kind of understand what is going on. And my personal experience about reporting is that the more analysis and work you can do for them, the better payout you get, and the faster they will patch a vulnerability. So you should think about how can you minimize their work. Don't let them try to understand your proof of concept. Don't let them start reverse engineering everything and trying to spot the vulnerability. So an example of a low quality report they have is that someone had just posted some code that triggered something, and that was it. Whereas the high quality report has a proof of concept, and it explains every step and explains exactly the functions that are involved and what is the root cause of this vulnerability. And some of my final remarks is that you will most likely fail many, many times, so fail fast. I fail many, many times, and things don't always go as planned, so expect the unexpected. And take your time to write a good proof of concept and a good report. Don't spend 3 months or 3 weeks finding a very nice vulnerability and then just submitting your proof of concept without any information, because then you will get a small bounty, and it will also take way more time for Microsoft to patch the vulnerability. And read some blog posts, do some patch analysis, and get inspired. At some point, all your previous work will be able to inspire yourself. But for getting started, I would definitely recommend taking a look at the blog post that already describes a lot of vulnerabilities, so you kind of get an idea of what we're working with, which techniques there are, and how simple some of these vulnerabilities can be. The patch process can take time, so from the time that you report it to you actually see your CVE. In my case, it took 6 months, and that is because I am reporting it through a third-party vendor, CDI, some of you may know. And so they have to review my case, and then they report it to Microsoft. So it takes a bit of extra time, but I also had a vulnerability that Microsoft was 9 months to fix. That was the certified 2.0. And sometimes things just don't work, and you don't understand why. But remember that you are exploiting a system. You are corrupting a lot of state you're not supposed to do. So just reboot your computer if it doesn't work, because magically that will fix everything. Happens so many times. So maybe you should work in a virtual machine to speed up things. You don't want to corrupt your host OS. And finally, remember to have fun. Any questions?
So it was awesome, man. Thank you very much. Thank you very much for this awesome talk. I don't know if anyone has any question. Maybe raise your hand. Yep, we have one there.
Hello. Okay.
Hello.
So congratulations. I mean, I'm not surprised, but amazed on the content of the security talk that you've already discussed so far. So congratulations again.
Thank you.
I have 2 questions. The first one is related to the last vulnerability that you were discussing about the arbitrary file read. What was the criteria for Microsoft to set to only CVSS 5.5? Like, what was that criteria? Weren't you able to escalate privileges, or what was the criteria for them?
So in my report, I actually made an exploit that could abuse this backup if that was the case. But the vendor, I reported this to CDI, and they were the one who gave me the CVSS score. But they have to be objective and say, what can the vulnerability really do? It can, so if you look at the CVSS score, there's some different impact metrics. So you have the availability, integrity, and confidentiality. And only the confidentiality, so leaking, reading information we're not supposed to be doing, was high. So the other ones were low, because we cannot affect the availability, and we cannot affect the integrity, like corrupting data. So that is why they give it such a low score. But a fun story is that they, CDI, paid me a higher bounty for the file reads than some of my privilege escalations. And the reason is that I was able to better explain it. and I was better to analyze it. And so CDI can better understand it. They can make some antivirus rules for it. They can easily report to Microsoft. So it's not always about the CVSS score. It's also how you report it. So probably the fact that I didn't explain my privilege escalation well enough took down the bounty and not the other way around.
Okay, thank you. And also, for those vulnerabilities that were related to the way that the attacker was interacting with the domain controller and the CA, right? From a blue team perspective, is there any detection mechanism to trigger any alert by, for instance, the vulnerability that you were tampering with the dollar and so on? So is there any detection mechanism from a blue team perspective? Because I mean, these vulnerabilities will come after and might arise later on in a different manner or way, right?
Yep.
But is there any way to at least be safe in terms of an APT or a cyber threat actor that might exploit this later on?
Yep, so that's a good question. I would say that user accounts and computer accounts are most of the times created by system administrators. So if you see some other user suddenly updating the attributes of another user, that looks kind of weird. Also, if you're changing some specific attributes like the user principal name, the logon name, that is a bit weird to change those, and also the DNS host names, because they are set once you create the computer. Whereas some other attributes like the password, we see that it's changed all the time. So you can actually do some monitoring on the attributes. I am not a blue teamer, so some of you are way smarter on this than I am, but that would be the thing that I would monitor, changes on some of these attributes that are way more static and not change that frequently.
Okay, thank you very much.
Thank you.
Awesome. Any other question you have in there? Okay.
Hey, thanks for the talk first. It's really nice to see so highly technical content here. So thanks for that.
Thank you.
And my question is, most of the or all of the vulnerabilities that you discussed were logic bugs, and I wonder what is your opinion on, because I'm seeing recently more and more vulnerabilities coming from memory corruption in the past and translating to more logic bugs, and I wonder if you think it's because we are getting rid of memory corruption, which I don't think so, but more that all the protections from the side of operating system, control flow guard, and also on hardware support for shadow stacks and things like that. You think that's one of the reasons why we are seeing more and more logic bugs these days, or if there is any opinion on that for you?
I think I have done some research on some memory corruption bugs, and this was a kernel vulnerability, and it was okay to exploit, but of course all the protections make it so difficult, and also the fact that you have to open up all the binaries, you have to find a vulnerability. That process is, for me at least, and probably for many others, way more difficult than just opening the print spooler, looking at the documentation, doing something weird. So I think it's both a mix of the security things that we are seeing, the mitigations, but also I just think that more researchers are focused on the logic bugs because they are fun and easy to understand, and the memory corruptions. I think even if you just have a buffer overflow that you cannot exploit, it should still be patched. But I just don't think that there are that many researchers looking at that. So we saw with the print spooler that there was, I don't remember, 16 vulnerabilities in 2021, 35 in 2022. And it's not like Microsoft completely changed anything about the print spooler. They did some years back. But all of a sudden, a lot of security researchers like me sees, wow, there are so many vulnerabilities here, maybe I should go there. And it turns out there was way more. Before that, before 2021, there had been like 10 for the past 20 years or something like that. So I think it's a matter of where the security researchers go.
Okay, thank you. Thank you again.
We have time for more questions. Anybody else? Okay, so I'm going to ask you a final question, man. Maybe people can think about other ones. So you have talked about a lot about reading other people's blog posts. You have talked about checking the patch of Windows, the new releases. And I'm pretty sure that a lot of people here now is interested in finding 0 days in Windows just because you made it look so simple.
It is simple.
I'm pretty sure people is thinking like, man, I'm sure I can do that. But I guess that one of the first obstacles, if you are not used to do this kind of stuff, is to learn how to read the patch files that Windows might be releasing. Is there any blog post you will recommend, any book, any way for introduction yourself to read these patches and try to find bypasses or new vulnerabilities?
Yeah, so as I mentioned, every second Tuesday of each month they have Patch Tuesday, so you can download all the patches. And there are some really great blog posts out there. I don't have the links here that I also read, and they tell you how you can download the patch without updating Windows, how you can extract all the files you need, and so on. But I think it's a bit more complicated approach, so I just like to take a snapshot of my VM, copy all the files, update it, copy all the files, revert to snapshot, and now I have my old vulnerable computer where I can test it. So yeah, patch diffing is a really nice subject, and there are some very cool blog posts about how to do it.
Awesome. Anybody else have any question? Yep, we have one final question in there.
Hi, thank you for your talk. I was wondering, because you commented that you report your vulnerabilities through a third party. Why did you take that decision instead of going directly to Microsoft?
That's also a good question. And the first vulnerability, Spoolful, I did report it to Microsoft, and 5, 6 months, I don't remember, 4 months later, suddenly my exploit wasn't working, and I had asked them for this whole period, do you need some more information from me? But they just patched it, and I had no communication with them, and so I just make a blog post about it, the vulnerability, and I look at the patches, and I see there is one CVE without any acknowledgement, so I just say, this must be mine. And then Microsoft comes back and says, oh, no, we're sorry, we didn't reach out, blah, blah, blah. And so I had a really bad experience with Microsoft, and on Twitter, I could see I was not the only one. There was a lot of people complaining about the way Microsoft did things. So their business model is to reward researchers. So you report something, they will fix it for sure if they think it's something worth fixing, and then they will reward you. Whereas if you report it to CDI, they are actually buying the vulnerability from you. So they will give you an offer. They say, we will give you $10,000 for this. Do you want to accept it or not? So if you say, no, I don't want to accept it, then you keep the vulnerability for 1 year. But if you accept it, CDI will create some antivirus rules. It's from Trend Micro. And then they will report the vulnerability to Microsoft. They will take care of everything. They will put pressure on Microsoft to have it patched. The thing is, you don't communicate with Microsoft no more, so you can CDI will not really keep you updated in that end. But I really like the way that CDI does things, and you can get some extra bonuses and so on. So it's just a matter of experience for me that I went with CDI. I like the communication way more.
Cool. Well, Oliver, thank you very much. It was a
Thank you.
very, very awesome talk. So
Thank you.